So yes, welcome to our new lesson, lesson 2. We are still introducing carbonyl compounds. In this lesson, we are going to look at the isomerism that exists in carbonyl compounds. However, before we look at the isomerism, we can review what we looked at in the previous lesson. In lesson 1, when we introducing, we ended by looking at the nomenclature. We said there are two classes of carbonyl compounds, and the aldehydes and then the ketones. Their nomenclature is quite different. We saw that if you had an aldehyde, we said these ones, the names end with letters A, L. Whereas for the ketones, we said the names end with letters O-N-E. And then we saw that if the number of carbon atoms is more than 4, then we tend to locate the position of the functional group. So we gave some examples that if you had like this one is having 5. So this, if it was an alkane, it will be called the pentane. But it is a carbonyl compound and a ketone. So we have to substitute letter O-N-E and becomes pentanone. However, again, the number of carbon atoms is more than 4. So we have to locate the position of the carbonyl functional group. Why do we have to locate the position? Because this compound consists of positioning isomers. If we shifted the carbonyl functional group to position 2, this compound has 5 carbon atoms as this compound, but the position of the functional group is different. So these compounds have to be distinguished so that they are not all called pentanone. So instead, we shall say pent, this one is position 3, or Ne. So pent 3 on, and then this one is pentane 2 on. This is pentane 2 on. So you find that this will go on as long as the number of carbon atoms is more than 4 within the carbon chain. But then we could have compounds with a benzene ring, and they are also carbonyl compounds. In that case, we said we shall always name the benzene ring as phenyl. And since these are 2 carbon atoms, the compound will be ethane. So we shall have the phenyl. Instead of saying phenyl ethane, we remove letter E of the N of the alkane and put letters O-N-E. So phenyl ethanol. That is a carbonyl compound with a benzene. What if there were 2 benzene rings? Two benzene rings. This was the benzene ring. So since the main carbon chain is having only 1 carbon atom, this compound is supposed to be a methane. But it's a ketone, though 1 carbon atom. So it is a methanone. But then what about the benzene rings, the 2 alkyl groups? They are called phenyl and they are 2, so we shall call it as a diphenyl. This is a diphenyl methanone. Diphenyl methanone. And so this is the nomenclature that we had not finished in the previous video that I wanted to highlight more about the nomenclature of ketones. Now, in this lesson, we are going to also look at the isomerism that exists in carbonyl compounds. Now, we know the classes of isomerism, and we say the most important type of isomerism is the structural isomerism. And so, these carbonyl compounds exhibit all the 3 classes of isomerism. So we can say we can say that the carbonyl compounds exhibit or have all the three classes of structure isomerism. Let's look at some example. What are these types of structure isomerism? Number one, we shall look at functional group isomerism. We want to see they are isomers to what? Let's take an example of C3H6O. This is an example of a molecular formula of a compound called the ketones. Ketones have the general formula, or carbonyl compounds have the general formula. General formula of the carbonyl compounds is CnH2NO. So if the number of carbon atoms is 3, then the number of hydrogen atoms will be 6, and then an oxygen atom. Now if we are to look at the functional group isomers here, we shall be saying that aldehydes with more than two carbon atoms, are isomeric or are isomers to ketones. You know, it is not possible to have a ketone with more than 3 carbon atoms. So most of the ketones will start with 3 carbon atoms and above. And in that case, it means that for 1 carbon atom, 2 carbon atoms, we can only have aldehydes. But we are saying aldehydes with 3 carbon atoms and above, that is more than 2 carbon atoms. Whenever you write their structure, just expect there is a corresponding ketone with that very general formula. And that means that the functional group isomerism here is between the ketones and the aldehydes. Remember, these two have the same functional group. But by the fact that one is a reducing agent and another is not a reducing agent, they have different reactions. There are certain reactions they will not be resembling. And so we can take them to be different classes. And so carbonyl compounds called the aldehydes with more than 2 carbon atoms will always be isomeric to a certain ketone somewhere. Let's look at this molecular formula given. If we are to write an aldehyde of 3 carbon atoms, then it will be CH3, CH2, CHO. How many carbon atoms? 3, just like this. How many hydrogen atoms? 3 plus 2, that's 5, and then 1, that is 6. So this is the first isomer we are writing, and the name of this isomer, since it is an aldehyde with 3 carbon atoms, then it will end with letters Al in the name. Instead of writing propane, we shall remove letter E of that alkane and add letters Al, such that we get the name propanol. Then the corresponding functional group isomer should be a ketone. And by all means, a ketone must have 2 hydrocarbon chain bonding or sandwiching the carbonyl functional group. And in this case, that will be the structure of our ketone. Name of this ketone, since there are 3 carbon atoms, if it was an alkane, it will be propane. But then we said we substitute this with letters O-N-E, propanone is our functional group isomer. So whenever we have 2 carbon atoms, whenever we have more than 2 carbon atoms, there is a corresponding functional group isomer to an aldehyde. Another example, what if we had C4H8O? These are 4 carbon atoms. So for an aldehyde with 4 carbon atoms would look like that. And then it is possible to have a corresponding ketone as another functional group isomer. So we will have CH3, C double bond, CH2, CH3. So the first one is a butanol. Why we are calling butanol is an aldehyde. But then this one is butanone, which is a ketone. So isomers of this nature are functional group isomers. Then let's look at another type of structure isomerism present in carbonyl compounds, and that is chain isomerism. Chain isomerism. In chain isomerism, the compounds are going to differ in terms of the arrangement of the carbon atoms within the carbon chain. Here, we are not after the functional group. We are after the arrangement of the carbon atoms within the carbon chain. So if we are to consider the general formula C4H8O, the first corresponding compound here would be an aldehyde with CH3, CH2, CH2, CHO. That is an aldehyde. Now, instead of writing 4 carbon atoms in a straight chain, we shall write 3, including the aldehyde group. So we shall have CH3, CH, and then we shall create a branch and then end up with that compound there. Now, this compound here is also an aldehyde. The difference is that this one is a branched compound, this one is not branched, and when we name them, both of them are actually aldehydes, and this one will be named as a butanol, whereas now this one, on the second carbon atom, if we are counting from the side of the carbon functional group, there is a methyl group, so this one will be 2-methyl propanol. 2-methyl propanol. So if we've been asked straight structure isomers of this compound, then it's very possible to have structure isomers in there. And what if these ones were 5? What if these ones were 5 carbon atoms? So we would have C5H10 and O. We can get chain isomers from here for both ketones and the aldehydes. For aldehydes, we'll have CH3, CH2, 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 those are 4, CHO. And that is an aldehyde called a pentanol, from the word pentane. Now, instead of 5 carbon atoms within the carbon chain, we would put 4 and create a branch, CH3, CH. This is a branch created. And then CH2, CHO. In that case, you will be having still an aldehyde. This time the main carbon chain has 4 carbon atoms, and so we shall be having the name as a 3-methyl. We are counting from the first carbon atom, which is the functional group. 3-methyl butanol. 3-methyl butanol. And then we could shift the position of the functional group, or we can create more branches. We can even create more branches and have CH3C. This is CH3. There's another CH3. And then, so far we put 1, 2, 3, 4. So we want to put the 5th one as the one carrying the aldehyde group. And so, If these are 3 in a carbon chain, then the name should be a propaner, the parent name, propaner. But there are 2 methyl groups within the carbon chain on the second carbon atom. So we shall have 2, 2, and that's a dimethyl. 2, 2, dimethyl, propaner. 2, 2, dimethyl, propaner. These are all examples of structure isomerism. It is even possible for us to create a ketone in this compound. We can create a ketone here and have CH3, CH2, CH. We can create the ketone in here, CH2, CH3. We can create structure isomers that involve ketones. If we, for example, I put here, let me put the ketone here and have CH2 here. That is a ketone. And so, if this is a ketone, then we can create a structure isomer of that ketone and have CH3 instead of 1, 2, 3, 4 carbon atoms or 5 carbon atoms in a straight chain. We'll put 4. CH3, CH, CH3. So we have C double bond CH3. That is a ketone that is branched. And we have 1, 2, 3, 4, 5 carbon atoms as in here. And the hydrogen atoms should as well be 10. These are 3, 6, 9, 10. So that is a ketone, but branched. And what could be the name? The name of the first one should be 1, 2, 3, 4, 5. So this is a pentane. If it was an alkane, it would be a pentane. But we said the ending is O-N-E. This would be pentanone. However, we said when there are more than 4 carbon atoms, then we have to look at the issue of positioning. Here, the position is 2. So this is pentane 2 on, and that is the final name we are writing. Now let's look at this ketone. 4 carbon atoms. This should be a butanone. But there is a methyl group within the carbon chain, and the methyl group is on the second carbon atom. If we, actually the third, if we count from this side, this is carbon atom number 2. So we are going to count from this side, and this one is going to be a 3-methyl butanone. That is what we call structure isomerism. Specifically, this is chain isomerism. But we could as well have what we call number 3, position isomerism. Position isomerism within carbonyl compounds. Now, it is only ketones with more than 4 carbon atoms that show position isomerism. Position isomerism. And a good example here, if we had the same molecular formula, you would have CH3, CH2CO, CH2, CH3. Those are 1, 2, 3, 4, 5. Then we could shift the position of the functional group from position 3 to position 2. And that is also another compound. These 2 compounds differ from each other by the position of the carbonyl functional group. Both of them are ketones. So we cannot have position isomerism within the aldehydes because the aldehyde group is always at the end of the carbon chain. That has been the isomerism of the carbonyl compounds. In the next lesson, we are going to look at how do we prepare carbonyl compounds. Thank you. See you there.